KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hi students, now we are going to start a new chapter, Laws of Motion. So, from the last chapter and before the chapter, we understood what is motion. Now we are going to discuss what are the laws of motion. So, most importantly, there are three laws: Newton's first law, second law and third law. But not only the laws, the consequences of laws. So, how the law is correct, and what about the force, and what about the inertia, what about the types of inertia, etc., etc. Okay, right. So, see here in this chapter, laws of motion, we will go on what is that sentence by sentence. Here the information is very important. So, my sincere request is, please try to concentrate on my explanation, because here we need to discuss many more examples, right. Statement is only one, but based on that statement we have to discuss many more examples. So, my sincere request is, please concentrate on my explanation also. Okay, right. So, before going to start the information, before going to start the discussion from this chapter, laws of motion, before going to start the explanation from this chapter, laws of motion, I will repeat once again, what is motion, right. If your body changes its position with respect to surroundings and time, then it is said to be in motion. I will repeat once again. If your body changes its position, if your body changes its position with respect to surroundings and time, then it is said to be in motion. Okay, right. So, what is motion? The position of your body is changing with respect to surroundings and time. Surroundings and time. Okay, right. Can you think that what is the cause of motion? Can you imagine that what is the cause of motion? For example, there is a ball. Somebody will come and kick the ball. Then the ball goes from here to somewhere, right. So, what is the cause of this motion? How your body is getting the state of motion? How a body is getting into the state of motion? How your body is getting into the state of motion? The answer is force. The answer is force. Okay, right. Now the question is, what is force? See here. Force is a pull or push of an object. Force is a pull or push of an object. Or another way of defining, force is a physical quantity. Force is a physical quantity which changes or tries to change the state of an object. Force is a physical quantity which changes or tries to change the state of an object, right. So, here state means state of rest or state of motion. State of rest or state of motion. Okay, right. Next, how the force is going to apply? How the force is going to apply on one particular object? Based on this, we can say that it is a contact force and it is a force at a distance. So, simply can say that applying a force in two ways. One is with physical contact, another one is without physical contact. The best example, when you are going to drink some water, simply you are going to hold the glass with your hand and you are going to dip that glass into the water and then taking to drink. Here, to drink some water with the help of glass, you are having a contact, you are applying some force on the glass, either to push or to pull it out from the water container. Similarly, when we are going for bathing, a bucket of water, we need to shift from one place to another place, right. So, here a bucket of water you are going to shift from one place to another place with the help of muscular force. So, their hand is in contact with the bucket, So, there itself, either to take a glass of water to drink or to shift the bucket from one place to another place, there the role of force is contact force. The role of action involves contact force. Okay, right. Here I also given some more examples. Say here, to move a football at rest, someone must kick it. So, here while kicking the football, the foot, right, the foot is in contact with the ball, right, that is. Afterwards, see some other example. To throw a stone upwards, one has to give it an upward push. Right. So, you know very well how to throw a stone. Otherwise, you take the example of cork ball. Generally, when we are playing cork ball, sometimes we are going to throw a ball upwards. So, that is also the example, either stone or ball. When you are going to throw upwards, you are giving some upward push, right. So, here this I already told you, pull or push of an object, force is a pull or push of an object, okay, that is right. So, what I am saying is in these two examples, not only these two examples, before this I told you two more examples. One is getting a glass of water, taking a glass and dipping into the water container and then taking to drink, that is. Otherwise, shifting a water bucket with full of water from one place to another place. Otherwise, kicking a football which is at rest. Otherwise, throwing a stone upwards. So, in all these four examples, here two examples I have written clearly and two examples orally I told. Okay. In all these four examples, you can understand the role of action which involves a contact force. So, based on this, you can say this sentence, external force is needed to retard or stop motion. Right. So, till now we discussed what is the role of action and what is the involvement of, what type of force exists in different cases, in different roles of action. That we cleared, it is contact force, right. It is a contact force. But now what I am saying is, just I am going to some other point related to this one only. External force is needed to retard or stop motion, right. So, come back to this example. To move a football at rest, someone must kick it, right. So, if someone kick the football, what happens generally? It rolls on the surface, right. Okay. How far it rolls? It rolls to certain distance. Afterwards, it comes to stop. What is the reason? Right. The reason is frictional force. In the same chapter, after completion of 2-3 classes, we will come to know what is frictional force and types of frictional force, etc. But till that you remember, In case of football, if someone is kicking the football, means, right, it is going to cover certain distance, afterwards automatically it comes to stop. So, for the stopping movement of football, the reason is, right, the reason is frictional force, right. So, here frictional force is the external force, So, now you can understand the last sentence. External force is needed to retard or stop motion. It is very important point, even though it is small, but it gives a lot of information about the actual situation related to the motion, right. So, external force is needed or required to retard or stop motion. To retard means to decrease the speed. At the same time, to stop motion also, either to decrease the speed of the object or to stop the motion also. Okay, right. Now, next thing, non-contact force or force at a distance. So, till now we discussed what is a contact force, and what is the role of external force to retard or stop motion of an object. Now, non-contact or force at a distance. Okay, right. See these examples. With these examples, you can understand clearly. Right? See this. A stone is released from the top of a building. Accelerating downwards. Accelerates downward due to the gravitational pull of the earth. A stone is released from the top of a building, accelerates downward due to the gravitational pull of the earth. Okay, that is right. So, here the motion of this stone is the example of force at a distance. So, you observe carefully, here simply we are going to drop the stone. So, after dropping the stone, because of gravitational force, the stone will reach the surface of earth. So, here there is no contact. So, gravitational force is the force applied by the earth which pulls the object towards the center of the earth. So, here that is the best example of force at a distance. Similarly, we will go for some other example. This example also you can experience, right. A bar magnet can attract iron nail. From a distance. Okay, that is right. So, here bar magnet is attracting nail from certain distance, no need of physical contact. So, that you can say that in case of this example, the magnetic force is the example of force at a distance. So, here gravitational force is the example of force at a distance, but here magnetic force is the example of force at a distance. Okay, right. Next, an external force required to keep a body in uniform motion. This is somewhat next continuation, right. See this, here what I told, external force is needed to retard or stop motion. Here what saying, external force is required to keep a body in uniform motion, right. For example, a body is in motion, right. When a body is in motion, if you want to continue that motion, continuously, also you need some external force. You need certain external force, that he is saying here. An external force required to keep a body in motion. An external force required to keep a body in motion, right. That is the general fact. So, this one and this one are the general facts. Okay, right. Next, uniform motion, next sentence, uniform motion is possible with no frictional forces. Uniform motion is possible with no frictional forces opposing, right. So, this one and this one. So, here what I told ma, external force is needed to retard or stop motion. Here what I am saying, uniform motion is possible with no frictional forces opposing. Suppose after kicking, when you kick a football which is at rest, it starts to move continuously. So, to continue that motion permanently or for long distance, right. Okay, you just imagine like permanently. Then what is the reason, what we need? Absence of frictional force, absence of opposite force, that is frictional force is required to continue the motion, right. So, that he told uniform motion is possible with no frictional forces opposing, with no frictional forces opposing, okay, right. So, this is the information about contact force and force at a distance, force at a distance. While discussing the contact force and force at a distance, we got 3 important points. So, these 3 important points you must keep in mind. One point is external force is needed to retard or stop motion. Another point is an external force required to keep your body in motion. Next point is uniform motion is possible with no frictional forces opposing, right. Okay. So, next one is the law of inertia, the law of inertia. It is very important for us, because this is like base, this is like the base for first law of motion, Newton's first law of motion, right. So, first we will come to know what is law of inertia. Before that, what is meant by inertia, right. So, what is meant by inertia, right. So, inertia is the unwillingness of an object and willingness of an object to change its state, okay, right. So, with example I will explain. Now, I told you what is inertia, but now I am going to explain the example. Suppose for example, we all are travelling in a bus. Suppose because of speed breaker or some other reason, bus driver immediately push the brake. Then what will happen? We all will fall towards in front, I mean just we will fall, immediately we will fall onto the, I mean what is the front seat, right, just before which is present, on that we are going to fall. So, why we are going to, why it is happening like that? Otherwise I will tell you one other example. Suppose we all are sitting in a bus which is at rest. Suppose if the driver came and he starts the bus immediately, then what will happen? We will fall backward, right. So, why these things are happening? Because when a bus is at rest, the peoples or the passengers who are sitting in a bus are also at rest. But when the bus comes into motion, if the bus comes into motion slowly, we also will come into motion. But when the bus comes into motion suddenly, because of inability of our body to come into the motion immediately, so we will fall backward. That is called as inertia. Otherwise, another example I will go through. For example, a doormat is there. Every day our mother, okay, is used to sweep the house. After sweeping the house, a doormat is there. So, we have to clean the doormat. So, how we are cleaning the doormat? So, we will take the doormat and we will hit the doormat with some other rigid body. Otherwise, you will take the stick and you are going to beat the doormat with a stick. Then what will happen? All the dust particles which are present in the doormat comes to motion, but because of inability, because immediately you are going to stick, immediately you are going to beat that doormat with a stick. Then because of inability, right, all the dust particles which are present in the doormat came into the falling, I mean came to fall. That only we need, no, that is only we need, okay, right. So, this is all about inertia. In future, I also will give you many examples because this is the important thing for us, right. Now, we are going to the topic. See here, it is the inclined plane, it is also inclined plane, it is the horizontal plane, right. So, in this inclined plane the body is coming down, on this inclined plane the body is going up, here the body is moving on horizontal plane, right. So, here the body is coming down, here the body is going up, here the body is moving on a horizontal plane, right. Here if we just drop the body, it automatically comes to reach this point. Here it won't go, here you need some external force, here also you need some external force, because the slope is 0 here, right. Here slope is present, but it is moving against gravity, it is going to move against gravity. That is the reason here we need some external force. Here the work is done by the component of gravity. In last class we discussed motion in a plane, we discussed what is the x component of a particular vector quantity and y component of particular vector quantity. Okay, right. Come to this. So, in these cases, right, so here we are going to drop a ball, then what will happen? It comes slowly like this, right, it goes. If you observe carefully, so how much height, from how much height you are going to drop the ball, here also the ball will reach the same height. Here also from how much height you are going to drop the ball, here also, because here this height will reach here at this point maybe, right. So, that is why from how much height you are going to drop the ball, it will reach the same height in this side also. But here the slope is 0, but whatever the height you are going to drop, it does not matter. Based on that the ball is going to travel more distance on this horizontal surface. So, that is the difference, right. It is directly linked to the law of conservation of energy. But what is the law of conservation of energy? Means energy neither be created nor destroyed, but total energy in this universe, remains constant, okay, right. So, that is only whatever I told here, that is only here again. So, in 1 and 2, in first and second case the ball will reach the same height, but in case 3 ball travels for longer distance, okay, right. So, to summarize, if the net external force is 0, a body at rest continues to remain at rest and a body in motion continues to move with a uniform velocity. This property is called as inertia. I already told you what is the inertia, that is unwillingness or inability of a body to continue its state. That only he has written in another format, such a somewhat big, right. See here, if the net external force is 0, the body at rest continues to remain at rest and a body in motion continues to move with uniform velocity. This property is called as inertia. So, what we understood from this information? Suppose a body is at rest. So, unless some external force is applied on it, it is at rest only, right. Next, a body is in motion. Unless some external force is applied, that body is in motion only, right. So, a body is at rest, it is at rest only, a body is in motion, it is in motion only, right. So, that is the information, right. Next, inertia means resistance to change, okay. In simple word, inertia means resistance to change its state, unwillingness to change its state. Next, a body does not change its state of rest or uniform motion on itself. A body does not change its state of rest or uniform motion by itself, okay. That is we are calling it as inertia or unwillingness or inability, okay, right. Next, see this, Newton's first law of motion. Next continuation topic, Newton's first law of motion, right. So, whatever we discussed here, that is only Newton's first law of motion. See this, if the net external force on a body is 0, its acceleration is 0. Acceleration can be non-zero only if there is a net external force on the body. If the net external force on a body is 0, its acceleration is also 0. Acceleration can be non-zero only if there is a net external force on the body. There is a net external force on the body, right. In both the ways he told, when acceleration is 0, what happens, when the acceleration is non-zero, what happened, in both the ways he told, right, that is. So, afterwards we have to discuss what is inertia of rest, what is inertia of motion, what is inertia of direction, right. So, inertia of rest is the inertia of an object, unwillingness of an object to change its state of rest. Inertia of rest is the unwillingness of an object to change its state of rest. Okay, right. For example, I already told you, some passengers are sitting in a bus. If bus starts suddenly, they fall backward because they are in the state of rest. They have to come into the motion, but they can't come immediately. That is the reason they are falling backward. So, here inertia of rest is the example. Inertia of rest is the reason. Okay. So, I will repeat once again, inertia of rest is the unwillingness of a body to change its state of rest, Similarly, unwillingness of a body to change its state of motion, is also said to be, is also called inertia of motion, okay, right. Next, inertia of direction, right. You know very well, for example, when we are going for Kolli Hills, right. So, there are so many turnings, otherwise Ooty, right, there are so many turnings. So, when the bus takes sudden turning from one direction to another direction, we will fall in opposite direction. That is because of inertia of direction. So, inertia of direction is nothing but the unwillingness of an object, to change its state of direction, is simply termed as inertia of direction, So, this is the three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Okay. If you understood clearly, the reason for Newton's first law of motion is inertia. No doubt about it. Okay, that is right. So, in this class, I explained you what is the cause of motion. What is motion? Already we discussed in the first chapter. Motion in a straight line chapter. But what I am saying is here, I explained you in this class what is the cause of motion. That is force. Okay. Then what is contact force and what is force at a distance? What is contact force and what is force at a distance? Okay. Right. So, what is contact force? I told you here with examples also. Then what is non-contact force or force at a distance? I told you with these examples. Then here I also told you three important points, this one and finally this one. Okay, right. So, afterwards we discussed what is law of inertia, and then we discussed what is Newton's first law of motion, okay, and then types of inertia also. Okay, but Newton's first law of motion not completed. We will continue that Newton's first law of motion in the next class. Okay, right.